What if you wrote a letter and burned it in flames? Turned to ash. Gone. But did it truly disappear? Physics tells us that information can never be destroyed. So what happens to information that falls into a black hole? Between 1974 and 1975, Stephen Hawking discovered something deeply unsettling. Black holes were supposed to emit nothing, yet he showed, theoretically, that they radiate heat. This is Hawking radiation. And this discovery gave birth to the greatest paradox in the history of physics. Quantum mechanics has an absolute rule. In an isolated quantum system, information is preserved reversibly. This is called unitarity. Yet black holes swallow everything, and eventually evaporate. So where does the information that fell in go? This is not merely a problem of calculation. This is a fundamental crisis in physics, where quantum mechanics and general relativity, two of our greatest theories, stand in direct opposition. By the time this video ends, the way you see the relationship between information and reality will have shifted at its very foundation. Chapter 1: The Last Testament of a Dying Star. Let's begin with a simple question. Imagine you write a letter to a friend and then burn it. Has the information in that letter disappeared? The physicists' answer is remarkable. No, they say. It has not disappeared. The molecules of smoke, the arrangement of ash, the vibrations in the air, trace all of it, and the information is, in principle, preserved reversibly. This is the foundational principle of quantum mechanics, unitarity. In an isolated quantum system, all information is preserved reversibly. Wind back time, and in principle you can return to the original state. This is an absolute rule, non-negotiable. Though in practice, whether that restoration is achievable depends heavily on computational complexity and interactions with the environment. But stand before a black hole, and this rule begins to waver. The radiation Hawking discovered is nearly thermal. Whatever falls into a black hole, an apple, a book, a human being, the semi-classical calculation shows the radiation follows nearly the same thermal pattern, which means at the level of Hawking's calculation, the information of what fell in does not appear to be encoded in the radiation. And here's where a crucial question emerges. When a black hole evaporates completely, where does that information go? Does it vanish from the universe forever? This is the information paradox. The absolute law of quantum mechanics and Hawking's discovery stand in direct opposition. And Hawking himself initially argued that information is destroyed. Yet in 2004, he revised his position and conceded that information is preserved. But the true mystery begins here. Physicists have spent half a century searching for the answer. Now, let's explore the hypotheses they've arrived at. Chapter 2: Firewalls and an Entangled Universe. Physicists attempting to solve the information paradox encountered a profound dilemma. There was a framework known as black hole complementarity. It tried to avoid the contradiction by arguing that the external and infalling descriptions can never be verified simultaneously, proposed by Susskind and others in the 1990s. But in 2012, a team of 4 physicists known as AMPS delivered a fatal blow. They showed a trilemma. Complementarity, the equivalence principle, and local quantum field theory cannot all hold at the same time. What they proposed was the firewall hypothesis. At the event horizon, there exists a wall of high-energy flames. Fall into a black hole, and you are incinerated the moment you cross it. The gentle passage that general relativity predicts is, they claim, an illusion. This was a shockwave. Because if true, it means the equivalence principle, the very foundation of general relativity, breaks down. Then, from an entirely different direction, another answer appeared. ER equals EPR. Proposed by Maldacena and Susskind, this idea makes a breathtaking claim. There may be a deep correspondence between quantum entanglement and wormhole geometry. Quantum entanglement is the phenomenon where two particles remain correlated no matter how far apart they are. EPR is what Einstein called spooky action at a distance. Let's think about what this means. If there is a deep correspondence between wormholes and quantum entanglement, the particles of Hawking radiation may be connected to the interior of the black hole. The information has not disappeared. It may be encoded within the very geometry of the universe. In 2022, An experiment was conducted using Google's quantum computer to simulate the behavior of this wormhole, sparking enormous debate. Theoretical physics hypotheses are edging closer to a phase of experimental verification. This is still a hypothesis. It has not been proven. Yet physicists are beginning to think something remarkable. The structure of space-time and quantum entanglement may be inseparable. And this question opens an even deeper one. What exactly is information? Let's look at the broader implications of this mystery. Chapter 3. The fabric the universe weaves from information. What the information paradox revealed to us was not merely a problem of calculation. It was a question about the fundamental structure of reality itself. There is a concept known as the holographic principle. The information of a black hole may be recorded in 2 dimensions on the surface of the event horizon. What if a 3-dimensional universe is inscribed on a 2-dimensional boundary, the way a holographic image is recorded on film? In the 1990s, T. Hooft and Susskind proposed the holographic principle. Then in 1998, Maldacena realized it as a concrete mathematical correspondence called ADS-CFT, revolutionizing theoretical physics. This is not a metaphor, it is a mathematically rigorous framework. I want to pause here and consider something. If information is the foundation of everything, what is matter? What is energy? John Archibald Wheeler said it this way: "It from bit, everything arises from information." Between 2019 and 2020, a significant breakthrough emerged. Teams led by Pennington and Almhiri independently used a method called the island formula to derive the page curve, which describes how information behaves, directly from gravitational calculations. It was suggested that a region called an Elitru island forms inside the black hole, contributing to the recovery of information to the outside. Information may not have been erased. It may simply have been scrambled to the extreme, diffused with extraordinary complexity, like smoke from burning embers. This scrambling is how black holes conceal information. But pay close attention to the phrase, "in principle." The calculations have been done. Strong theoretical evidence has accumulated that information is not lost. But how that information is implemented in the language of gravity, the internal picture, the mechanism, remains an active area of research. Let's think about what this means. What if the darkest place in the universe, the black hole, is teaching us the most fundamental truth about the nature of reality? What if information is as fundamental as matter and energy, or perhaps even more so? I find myself filled with profound awe at this. What we thought had disappeared had not disappeared at all. The universe does not lose information, no matter how extreme the conditions. And here's the ultimate shift in understanding. The black hole information paradox has tilted strongly toward the conclusion that information is not destroyed. But the question of how that information is implemented remains open. The unified theory of quantum mechanics and gravity, the final dream of physics, may be revealing its contours through the concept of information. Now, let's bring together what this exploration has uncovered. Chapter 4. The Quest That Never Ends. Today, we've ventured deep into the black hole information paradox. Hawking's discovery of radiation exposed a fundamental contradiction between quantum mechanics and general relativity. In the quest to resolve it, extraordinary ideas were born: the firewall hypothesis, ER equals EPR, the holographic principle, and the island formula. And the question was opened. Information itself may be the most fundamental constituent of reality. Let me share 3 profound insights from today's exploration. First, information cannot be destroyed from the universe. Recent theories like the island formula have provided strong evidence that information is not lost. Even when a black hole swallows everything, the information may simply be scrambled to the extreme and diffused throughout the universe. This is a claim about the fundamental structure of reality itself. Second, the geometry of spacetime and quantum entanglement may be deeply connected. What ER equals EPR suggests is that there is a profound correspondence between wormholes and entanglement, which means the very geometry of the universe may be woven from quantum information. In 2022, an experiment was conducted attempting to simulate that behavior on a quantum computer. Third, the questions we cannot yet answer are what drive physics forward. The challenge of the information paradox gave birth to the holographic principle to add S, CFT, and open the path toward quantum gravity. The courage to remain with a mystery is what cuts open the frontier of science. These three insights are not separate. With information as the center, quantum mechanics, gravity, and the geometry of space-time are trying to become one. We are standing at the place where we can just barely begin to see the contours of that unification. Making this video, I found myself stopping again and again. Information, an invisible abstract concept, sits at the very heart of the mystery of the most extreme place in the universe. This may be a suggestion that at the foundation of what we call something existing, there is information. The greatest mysteries in physics have not yet been fully solved, but that's precisely what makes them beautiful. Here's what I want to ask you. If information is as fundamental as matter and energy, is reality nothing more than a pattern of information? And if you yourself, your memories, your experiences, your thoughts, are inscribed in the universe's information, what does that mean? These questions have no answers yet, but continuing to ask them is what brings us step by step closer to understanding the universe. That journey has only just begun. After this video ends, when you return to your daily life, I want to ask you to notice something. When you write a letter, take a photograph, exchange words with someone, there is information there. And by the laws of quantum mechanics, that information cannot be erased from the universe. When we leave something behind, it may be inscribed in the universe in a very physical sense. The darkest place in the universe is illuminating the most fundamental questions about reality. In the midst of daily life, take a moment to think about the permanence of things unseen. Share your insights in the comments below. Your questions are the force that drives this channel forward. I'm grateful you joined this intellectual journey all the way to the end today. The mystery of black holes and information, the clash between quantum mechanics and gravity. This is a question at the very frontier of physics. At Mindshift, we explore themes like these, the cosmos, consciousness, and the foundations of existence, diving deep into one question at a time. If you want to keep confronting an exploration where the deeper science probes, the deeper the mystery grows, subscribe and turn on notifications. Your curiosity is what drives this channel forward. Until next time,